The incredible engineering skills of the ancient Romans are on display in these magnificent buildings, which not only stand as a testament to the majesty of the Roman Empire, but also as a testament to the extraordinary engineering abilities of the ancient Romans. As a result, get ready to be amazed as we delve deeply into the interesting secrets that are hidden underneath these majestic aqueducts. Do images of towering arches that rise to the horizon in the far distance come to mind when you hear the term Roman aqueduct? In point of fact, arches only made up a minor percentage of the conduits, with the great majority of the conduits being submerged beneath. This design was not only more economical, but it also prevented aqueducts from becoming eroded and reduced the influence that they had on the crops and neighborhoods that were located in the surrounding area. For instance, the Aqua Marcia was constructed in 140 BCE and stretched for approximately 92 kilometers, 57 miles, but it only had about 7 miles or so of arches along its length. Before beginning construction on an aqueduct, engineers would determine the suitability of a potential water source by taking a sample of the water and analyzing its clarity, flow rate, and flavor. This would be done prior to beginning construction on the aqueduct. In addition to this, they observed the health of the natives who consumed it and made notes of their findings. Once a location had been selected, surveyors determined the conduit's channel size and length, in addition to its acceptable path and gradient. Clearly, slaves were used as a source of labor. The construction of an aqueduct could take years, which increased its overall cost, particularly if arches were required. Aqueducts were also required to have regular maintenance and protection. At one point in time, the city of Rome employed close to 700 people in order to provide medical assistance to its residents. The design also included provisions for maintenance so that it could be maintained. For instance, manholes and shafts were constructed in order to provide access to the subterranean portions of the aqueducts. Engineers were able to temporarily reroute the flow of water away from a damaged piece in the event that major repairs were required. By the beginning of the 3rd century CE, the city of Rome was served by 11 major aqueducts. The first one, known as the Aqua Appia, was built in 312 BCE and stretched for a little over 10 miles, 16 kilometers in total length. It traveled almost entirely subterranean the whole length of the route. The Aqua Claudia, which formerly covered a distance of more than 43 miles, 69 kilometers, in length and contained over 6 miles, 10 kilometers of arches, some of which stood 90 feet, 27 m in height, is still maintained in part today. The length of the Aqua Claudia has been reduced slightly. How much water was transported through the city's aqueducts? A lot. The Aqua Marcia, which was discussed earlier, was responsible for bringing approximately 190,000 cubic meters, or 6.7 million cubic feet, of water into Rome each day. When the water eventually reached metropolitan areas, gravity was the force that drove it, and it began to flow into distribution tanks. From there, it flowed through branches, which channeled the water to other distribution tanks or to spots where it might be used. After the water reached the metropolitan center, gravity took over as the primary driving force. Some people believe that the water distribution system in Rome developed to the point where it was able to provide more than 265 gallons, 1,000 liters of water per day to each resident of the city. Rome required a consistent and ample water supply to suit the requirements of its residents, public institutions, and big architectural projects. This was necessary because Rome's population was rising and its urban landscape was flourishing. The Romans constructed a vast network of aqueducts that spanned enormous distances and made use of the power of engineering in order to transport water to the core of the city. This was done so that they could supply the urgent demand for water. The aqueducts were not merely straightforward channels. Rather, they were complex, technical endeavors that required meticulous planning, specific building techniques, and sophisticated networks that extended over considerable distances. This meant that the construction of the aqueducts was no easy task. It is very astonishing that many of these aqueducts have survived the test of time and can still be seen today. This serves as a testimony to the outstanding skills of the ancient Romans. In order for us to acquire an appropriate appreciation for the magnitude of these architectural accomplishments, it is necessary for us to first comprehend the building practices that were utilized by the Romans. The procedure started with careful planning and mapping of the land. during which experienced engineers and surveyors chose the most effective routes for the aqueducts to take through the landscape. To completely comprehend the colossal feat of these aqueducts, we must delve into the construction techniques adopted by the Romans. The procedure started off with a thorough preliminary investigation and careful planning. Skilled engineers and surveyors would traverse the landscape in order to conduct an analysis of the topography, determine the potential locations of water sources, and locate the pathways for the aqueducts that would be the most efficient use of the land. Roman engineers were known for their pinpoint precision. They used a variety of instruments, such as the groma and the dioptra, to make precise measurements of the angles and distances involved in the project. They methodically analyzed the gradients and heights using these techniques, ensuring that the slope was not too steep and that water could flow downhill in a steady stream. They were able to accurately follow the natural contours of the ground because of the careful planning that went into the construction of the aqueducts. This not only boosted the efficiency of the aqueducts, but it also decreased the number of support structures and excavation that was required. Let's talk about the arches now, because they are the most recognizable part of the aqueducts. The Romans were the first people to use arches in building, and they used their superior strength and stability to build monumental aqueducts that defied the laws of gravity. They constructed aqueducts that carried water over enormous distances by merging several arches into a single construction to make aqueducts that spanned great distances. These aqueducts carried water over valleys, ravines, and even rivers. The different kinds of topography that the aqueduct arches had to traverse required different architectural layouts for the arches themselves. Arches were constructed to be relatively low and supported by piers or columns in areas that had a flat terrain because these locations were ideal for their construction. However, in order for the aqueducts to be able to traverse the mountainous terrain, higher arches had to be built. Because of this, the aqueducts were able to perform their intended functions successfully. The Pont de Gard in France is one of the most well-known instances of this architectural masterpiece. It is a three-tiered aqueduct with enormous arches that reach up to an incredible height of 160 feet. However, the Romans did not rely solely on arches as their structural solution. When they came upon hills or mountains where it would have been impractical to erect arches, they turned to a different innovative method: tunneling. These tunnels allowed the aqueducts to retain a direct and efficient route, bypassing impediments and keeping the water flow. The excavation of these tunnels was already an outstanding achievement in its own right. Roman engineers painstakingly carved through hills and mountains, using precise measurements and calculations to ensure the structure's stability as they went. It was common practice to line the inside of the tunnels with watertight materials like concrete or tiles. This had two purposes. It prevented leaks and ensured that the water that traveled through the aqueducts was of the highest quality possible. The Romans considered the upkeep of the aqueducts to be a task of the utmost importance. They meticulously erected settling tanks and sedimentation chambers along the aqueducts so that impurities could be removed from the water and the water supply before it was delivered to the city. From there, the purified water was distributed through an enormous network of pipes, providing the numerous fountains, baths, and public facilities of Rome. It is truly mind-boggling to consider that the aqueducts of Rome stretched over a distance of more than 400 kilometers, 250 miles, bringing water from far-off sources such as springs, rivers, and lakes. This is something that truly should not be taken lightly. Rome was able to flourish as a city and sustain an empire thanks to the engineering ingenuity that went into building this massive network of aqueducts. This contributed significantly to the city's overall growth as well as its cleanliness and overall development. It is impossible not to be awestruck by the ancient Romans' foresight, creativity, and pure skill as one makes their way through the ruins of these remarkable constructions. The aqueducts will always be visible reminders of the engineering expertise that they possessed, as well as their unwavering dedication to technological advancement. They were not only responsible for providing water, but also for the building of the urban landscape, the promotion of public health, and contributions to Rome's economic development and cultural development. An enduring tribute to the engineering brilliance of the ancient Romans, the extraordinary aqueducts of Rome are presented here for your perusal and admiration. Don't forget to give this video a like, subscribe to our channel, and share it with your friends. Also, feel free to let us know in the video's comment section which engineering marvels you'd like us to look at next. Maintain your inquisitiveness until then.